There was, there wasn't the fidgeting that we saw yesterday, so that was good. I thought your introduction was good. I made a comment about the first slide. Can we go to the first slide? I just want to see. I didn't see exactly what it was. Oh, so let's go to the second slide. You said that you did 4 systems, and my eyeball zeroed in on this. I saw 5 things before I realized the 5th one was the conclusion. You might want to maybe just say these are the 5 systems and leave the word conclusion off there. Excuse me, 4 systems and leave the word conclusion off there. Again, small detail, not a big deal. A couple of your slides, let's just go to slide 8 as an example. A couple of them look like they were cut off at the bottom. Is that cut off, or did you just get close to the border there? You see, it almost looks like the last line on the
Sorry,
bottom.
it's cut off. The previous slide is the other half of the system.
Okay.
So it's like one slide I show half the system, and the other slide I show the other half.
All right, because I was going to make a comment that I liked what you did with some of the other drawings, where you show the whole drawing and then you zoomed in immediately onto the section that was relevant. I thought that was a good idea. I actually haven't seen that done before. Because I was going to make a comment saying, oh, gee, I can't make out the details of the drawing, and all of a sudden you zoomed in on a spot. So I thought that was good. I think you should probably consider using that more in the presentation. Maybe this is a good example where you show the whole drawing and you say, okay, we're going to zoom in on this part. All right. Slide number 10. You said seawater at, and from a distance, that looks like minus 90 degrees Fahrenheit. I think what you meant is that
it's the approximate.
Yeah, like I said, from a distance, it looks like minus,
Sure.
But I understand what you're saying. It's like you designed for a maximum of 90 degrees. You just might want to reword the sentence there to make it obvious that it's designed for a maximum of 90 degrees in words of similar effect. You know what I'm saying?
Yes, sir.
Slide 13. It just went too fast. I couldn't see. Port and starboard, 400,000 cubic feet. All right, that's good. That's good. Again, that went kind of fast. I thought there was a mistake there. The inert gas generator, I think you should mention what you're burning to create the inert gas, since we've got lots of different stuff. We got the LPG, we got ammonia, we got, actually ammonia you can't make inert gas with, but you got MDO, so just make it clear what you're using to create the inert gas. You use the expression, this is a cool drawing. Yeah,
That's a cool drawing, but
it was a cool drawing, but like I said, it's,
really cool.
Totally baller, yo.
And that's really the things that caught my eye. Like I said, I thought it was a good presentation. So.
From the start where you introduced yourselves that you're kind of staggered, and I got 2 guys in the background there that I would say all 4 of you stand shoulder to shoulder to begin with and introduce yourselves, and then you can shuffle into the back if you want. Where do you buy a 57 horsepower motor? And how much is a 57 horsepower motor?
I have those details in the report. It's from.
And compare that to a 60 horsepower motor.
Would you like me to explain that within the presentation?
Well, what I'm getting at is, can you buy a 57 horsepower motor?
You can if you know where to look.
Okay, where are you gonna look for that?
The manufacturer.
ANC, I believe it was. I have it.
And let's just say there's a supermarket that has pumps for sale. Do you think there actually is gonna be a 57 horsepower on the shelf there for you?
Yes, sir.
Okay.
Well, I have the pump here. It's an 811 ANSI.
I can see what it says there, but my point is that there's no such thing as a 57 horsepower motor.
So should I say
You're gonna have, well, one, you have to look at the catalog to see what motors are available. That there's maybe 50, there might be a 60, there might be a 70, might be a 50, all the way up to a 75.
Well, that's what I did. I found the motor in the catalog, and then I that's what I
But
have.
then you should write that on there as far as here's the motor that we want, or show me the calculation that we had a 57 horsepower, but we're picking a 60 horsepower or 75 horsepower to fill the need for this particular pump. So again, I don't think that there's a 57, and for that matter, you have all these different pump sizes that they need to be rounded up. Slide 14, that could you, or is there a regulation that, why can't you fill and suck from the same line as far as cargo?
You could,
Why do you want to go with 2 lines?
just for safety reasons, it made more sense to have 2 different lines, considering the outfittings.
Well, now you're doubling the cost.
That's true, but in the grand scheme of things, the cost estimation that we had, the cargo piping is not going to be that significant for this.
Okay.
Worth it.
Slide 17. Is there just one of these, and is that, you said that it was supplying 96, or has the capability of supplying 96?
Yeah.
Why not having several of those going around? That, it just seems like that's gonna be your Achilles heel. If that goes down, then all your control valves are going down. And I know that, yes, it's got some redundancy as far as 2 motors on it. But again, piping wise, that here's the bow, here's the stern, then if I get a little hole somewhere in that line, then that whole system is down, and I now need to figure out where that hole is.
That's true. If the people buying the vessel wanted multiple of them, we also have the cost information for that. We
Okay.
could account for having 2 of
You
those.
got answers. Slide 26. Actually, go back to one slide. I think you kind of went too fast with the inert gas generator, or a couple of those slides, as far as getting what Professor Totores was talking about. Go one slide more. That, again, I like the picture. I know it's your drawing in your project, but yeah, maybe bring out some of these, or throw darker lines in there that here's where the inert gas unit is. That I'm just looking at this whole picture, and you say X, Y, and Z as far as here's the components going for it. So let's highlight X, let's highlight Y, let's highlight Z, and like I said, that yeah, maybe zoom in, bring it out, or blow up the lines a little bit so it stands out, or for that matter, get a laser pointer that here's where this particular item is.
Okay.
One more slide, that 26, good 26. One more. That vent at the bottom, how's that working?
Yeah, it's just the arrangement of the drawing that was on
Will it just
Blackboard.
grow in there, that
I should have, yeah.
little mushroom on the back?
I think if you move it all the way to the right, flip it, and then just run it all the way to the top.
Yeah.
You know what I mean?
The top view?
Yeah,
Okay, that's all I got, thank you very much.
thank you.
Okay. Slide 22, is it formatting issue 22? It wasn't 22. It was the one that had the oxygen and CO and CO2. You just went by it, I think. There we go. You got carbon monoxide is in italics for some reason, oxygen looks like it's in italics for some reason. Any reason for changing font
Those-
styles?
Yeah, those are the 2 that I highlighted and spoke about, so I wanted to make them look different.
I would keep them the same.
Okay.
Okay. Also, I'm not sure why you went with smaller text on the left and larger text on the right. It looks like maybe you're trying to keep them the exact same length. I think you're better off using the same font sizes.
Okay.
Did you ever define what PV stood for?
When I said the PV breaker, I said it
Okay,
the first time.
okay,
I
I
could
missed
write
that,
it
I was
down.
probably writing, and then every other time it was PV, so that's fine. Just wanna make sure that was covered. Similar comments about the drawings. One, make your drawings, yeah, that's a good example right there. You don't need the title block on here. I would make a separate drawing that's less busy for your presentation. if you're going to keep it like that, the alternative is to do what was done before, where you, blow up the sections. It's
Okay.
fine, cause it's kinda busy, it's kinda hard to read, but if you're immediately going into talking about, well, here's this section I'm talking about, here's this section, you're blowing it up so it's easily read, that's a fine way to do it also. The other thing is, if you're not gonna blow the screen up, the one where you talked about the seawater system, the IT system, it was all in one drawing. If you're not gonna blow the sections up, which is one option, and is a good one, put dashed lines around each section so that you can say, and then you also need the laser pointer to direct the attention to that particular section. Because it's a fairly significant sized drawing, and you're talking about different sections of the drawing, and we can't really follow that quickly, where you're going.
Okay.
All right, on wherever you talked about, was that 16 maybe? Try 16. Maybe not. Oh, there was a place we talked about 30,000, and it was actually 40,000. You gave the wrong number at one point, so just be clear. But maybe it wasn't that slide. Try it. On that slide, the slide with the pump, the text is really hard to read. But there was a slide. Maybe somebody else caught it.
Is that the one that I was looking at, 13?
No, it was just a misread number. On one of the slides, you said 30,000 versus, and when the slide had 40,000, I think, or vice versa. On your drawings, overall consistent line weights. You've got heavy lines here, your other drawings are light lines, kind of inconsistency in what we're looking at. And that, so to me initially, because you have inconsistent line weights, I'm thinking, oh, this looks maybe as an electrical diagram, because it's got the typical jumps that Professor Gardner doesn't particularly fond of. Yeah, I've had the comment about the pointer as well. If you can get a pointer, especially, I think, Professor Tutori, you have that pointer that works on the screen so that transmits better, because if you show a pointer on there, it's not very good. So if we can work that out, that's great. If you got something else, the popping also works just as well to highlight.
I just have a conventional laser pointer.
Okay.
I think Aiden has a pointer too, but.
I do own a laser pointer.
Yeah.
We practiced with them, we weren't too good at it.
Yeah, so is a laser pointer that's on the computer, or not really a laser pointer, but a pointer that moves around on the screen?
Okay.
Yeah, as opposed to on the, yeah, that's what you really need, because we're doing it with Zoom. So if you can get that and master that, that's helpful. 19, just whatever that text is at the bottom, it's meaningless because it's a blur.
Starboard manifold?
And kind of at the top of the
Yep.
lines there, you just make sure that it's legible. That's all I got. You did a good job. Just need to polish it up.
Okay, yeah, I would agree, just, that you should practice more. Slide 33 and 35, you mentioned which CFRs. So same comment that was made yesterday, that's good, I like that. I would be consistent with it, I would add, you're talking about CFRs, but I would add those. Which is actually, you guys are watching these presentations, you haven't gone yet, you can take some of this feedback. If you're not goofing off when the comments are being made, you can
Not making
make
the same
some
mistakes.
adjustments to improve yours, improve your presentation. And with that said, I like that you're taking notes over here for feedback. You have your videoing it, so that's good. You can watch it back and see how you can improve. So yeah, good job.
I hear you only charges $50 per section too, so.
That's actually really cheap.
Well, that's 60.
What can I say?
Done?
Mm-hmm.
All right, nice presentation. I really like the drawings. There's a lot that can be done to improve them. We'll talk about that a little bit. But let's start with slide 5. most of the stuff's already been said, but like, there's a couple places where you have duplicate arrows. Like there's so many arrows going on. Like on the very first top line, it's horizontal. You got 2 arrows that are maybe 2 inches apart from each other in the scene, right? You can simplify it a little bit. Some of the stuff. Slide 9. A lot of the other stuff's already been mentioned, so I'm not going to repeat it. I can't read my copy. Let's go to 10 instead. AMOT 3-way mixing valve. How is that controlled? So temperature control valve. How is that controlled?
Electrically.
Electric. So you have it's a electric.
Electric
Motor
actuator
operated
on the
valve.
top.
What's that?
Electric actuator on the top.
It's electric actuator. Okay. All right. Just wanted to make sure that was considered. All right. 11. A couple of concerns here, and this is going to be an issue when we. And this is a big feedback that we get from the panel, the industry experts, is working together with other groups. So here we talked about, okay, you're gonna be able to fully discharge the ship in 15 hours. Yesterday the groups, their ballast system was 24 hours to ballast the ship. Have you guys worked together? Did you guys link up on that?
We did. We talked about making sure the pumps have similar capacities, which
Okay.
their ballast pumps are slightly larger than the
Okay.
other pumps.
All right, but I would just be concerned, okay, the ship can discharge in 15 hours, but now are we stuck in port for another 9 hours because we're still ballasting, or maybe ballasting can begin before or after? But I just want to make sure we're working together, because that's going to be a big question on the day of, big presentations, all right? 14. So this fill line, and I'm not too keen. Is this for filling ammonia? Is this for filling LPG? Both? What?
Both.
Both. Okay. So this tank can hold either, right?
Yeah.
All right. So we got a fill line on the top. It looks like it's coming in through a spray nozzle. I imagine that's what that symbol is, or is it just a pipe that terminates at the top and dumps it into the tank? What do you got there?
That's the nozzle. The CFR recommends nozzles because it helps keep the tank cool.
So for tank cooling, okay. Okay, that's what I would think. So it's good for tank cooling, but it's not good for tank filling speed. That's because it slows it down. So I don't know specifically for LPG or ammonia, but for LNG, you'll probably have a spray nozzle at the top, but also a fill line that goes to the bottom, so you can fill fast from the bottom, you can spray from the top for cooling, and so I would just be concerned that you're slowing the process by having it go through a nozzle at the top there. So that just brings a concern to okay. Another thing is, I don't know if you guys mentioned anywhere about materials, right? So dealing with LNG or LPG, dealing with ammonia, specific materials are going to be required. So for the pumps, for the piping, I would be sure to mention that. Okay. 25, yeah, that was a really cool picture, but also, I wouldn't put it that way. All right. I think that's it for my comments. Some, if you guys wanted to see me about the drawings, there's some things we can talk about, but they were good drawings, but they could be cleaned up. A lot of stuff's been mentioned about like the border being shown, the way you zoom in, or maybe simplify it. It could be improved upon, but they're nice drawings, but work to be done, yeah.
So with those drawings, when we present on April 24th, we're gonna print out our drawings for them, right? So if it's like too small to read the words, they're gonna have the drawings in front of them, right? So
Well, are
Yeah,
you
we're gonna, at about probably the middle of April, I'm gonna have everybody send me PDFs of their drawings, and we're gonna email them to the industry guests, all right?
okay.
And I'll probably print out some packages, because we'll have some in-person guests. And I'll, print out some paper packets for them.
I would still yes, and that's good, they'll be able to have it right in front of them, but I would still incorporate a way of pointing to this is
Okay.
what area of the pump that I'm looking at, the component that I'm looking at, in some way to highlight that we know where to draw our attention to.
Got it.
Can you go back to slide 9 again? I think I might have realized what my question was. It was the slide, and that wasn't here. It was the slide where you call out the temperature of the fuel. No,
So, fuel.
that wasn't it. Wait, I think you just passed it. Sorry.
Cargo temperature?
Yeah, here we go. LPG stored at -44, ammonia stored at -28 Fahrenheit, which I know that's what the, and this might be a question more for the advisors too. I know like the ABS, like when they're defining what a cryogenic product is, it's all in Celsius. Like, should they put it both, you think, or what do we think?
What's that?
Like when you look it up in the ABS rules, like what's a cryogenic fluid? It's, you call it out in Celsius, not Fahrenheit. And I know they've been instructed to put everything in English standard units, but
Are you suggesting that they also put it in Celsius?
well, that's what I'm asking. Yeah, what do you think about that? Just for something like this, that typically if you look it up somewhere, it's going to be in Celsius. Okay,
Yeah, I think it's
The
less,
metric system.
I think it's less
I'm with
confusing.
you. I'm with you.
I think it's less confusing to just have one.
It's less confusing. Okay.
And as I think Mr. Pike said, these are not cryogenic temperatures, cryogenic.
And yes, that's true. But I'm trying to like go back in my
To the way they
in my
write the
head,
rules.
because I've looked
Yeah.
up the ABS rules.
Yeah, so anybody that's smart enough to look up the rules is gonna be able to go, let me
Most
see,
people don't know
44,
that minus
minus
44
44, blah, blah,
crossover
blah,
temperature
yeah,
is
you know.
Yeah.
close enough to that.
Yeah, that's true. You're right. That's fine.
And it's true, minus 44 is about minus 44.
Right.
So right there.
Okay, just a thought. All right. I agree. No, I'm with all of you, but I'm mostly with you. All right, good job, guys. Go ahead.
Thank you, sir.
Attila.
Hello guys, good job, good presentation. Most of the subjects that I wondered, the other professors already asked, but I have a few more things. I agree with the idea, you should your explanation, especially while talking about the diagram and the system with a pointer or ruler or the mouse, you know. On slide 15, yeah, okay. Polyurethane insulated tanks, there's a coefficient here. I know the meaning of this variable, but you would mention there, okay? What is the name of this coefficient, okay? And for the diagram, except fire suppression system, I had hard time to read from here. So it was a good idea to enlarge partially, you know, the system and, you know, make the definition. And in 26,
Before you, I'm sorry to interrupt. Before you change the slide 15, you showed the tank. What type of tank is that?
yeah,
Type A, Type C, maybe it's Type B, probably not. Type A or C.
But I'm
Okay.
pretty sure I mentioned that, but I can put it on the slide.
It was mentioned somewhere.
Yeah.
You did mention it.
All right.
I'll put it on the slide.
I think I've put that on the slide. Sorry.
Yeah, you got proof.
Take a replay.
I believe you. I just didn't see it written there. Go ahead, Till, sorry.
26. Okay,
Next week start.
so I was wondering how did you do the ventilation design
Yeah.
in the lower ballast tanks? Plus, you would put the capacity as well.
Okay.
And in fire system, for the carbon dioxide, fixed carbon dioxide system, how many tubes do you have there? Did you mention that? How many tubes
The
in
nozzles,
the fixed carbon dioxide?
there should be 62 total nozzles.
So did you
I did not
put it
mention
there?
I did not mention that.
Okay, you would mention
Yes,
that.
sir.
And And I didn't see any calculation. Did you calculate anything here?
Yeah, that was mostly mainly in the report. We didn't know if we should add that like as another section, because we knew that there was gonna be a time crunch, so we can rearrange some stuff and add that.
I think you were mentioning about the sprinkler system, the pump capacity of 55.5 GPM. You will show at least one calculation, how did you do that, okay? It will be nice. Thank you so much. That's all.
25, I think it was.
Really cool picture.
26.
26, yeah.
Something that you might want to do is, you guys with the cargo, not the ballast group, right? So maybe put that ballast stuff on a layer that's gray, so it kind of like fades to the back. It's there, yes, it's there, and, right? But maybe like face the background in this. You get a lot of comments on ballast, and you guys weren't even ballast.
Yeah.
So I would like maybe gray that stuff out. We're after the cargo tank, that's what we're
Like flash.
you know what I mean?
Okay.